All right, first problem we're going to look at, dividing monomials. Instead of adding when we are multiplying, we're going to be subtracting because we're dividing. So we're going to look at this first example. So what we're going to do is we're going to look at the next slide and kind of expand this particular problem. So meaning writing it just a little bit differently. So we've got our problem, and I'll just move the slide down so that way we can just focus on one thing at a time. We first ask ourselves, what times what will give us 15? And then we say, well, a to the third power is written out a 3 times, b is written out 7 times, and then we'll look at the bottom as well. So here I've got 3 times 5, because that's 15. I've written out a 3 times, and b 7. So we're going to do the same exact thing with our bottom part. And at any point, if you feel that you need just to pause the video, just to take down some notes, go right ahead, so that way you can kind of just keep up with what I'm talking about. The bottom piece is just going to be that 6a squared times b. So I'm going to write 2 times 3. A is twice, and then you have your b. So as we move on, we're going to start to cancel out some things. I see that they have a 3 on the top and a 3 on the bottom that I'm going to eliminate. I've got 2 A's that they have in common and 1 B. So what we do is we look at what's left. A 2 on the bottom, a 5 on the top, an A, and then 6 B's. So to write out our answer, we're going to write 5A, b to the 6th power, all over 2. Alright, I want you to try these two problems, kind of expand them, and then simplify. And I'll give you a few minutes to do that. So you can also pause the video while you're working on those problems. Alright, so let's look at this first one. We've got 5 A's on the top, because that represents our A to the 5th power. We have B 8 times. And then that's all over A times B times B times B. So when we cancel, we're canceling out 1A and 3 B's. So let's look at something. Isn't that the same thing as just taking 8 and subtracting 3 from it to get b to the 5th? Because that's how many b's are left over on the right-hand side up here. So what we're going to do is we're going to write out the problem a to the 4th times b to the 5th, because all of our letters are in the top. When you look at the second one, let's just try, instead of expanding it, just subtracting the exponents. So let's start with the t's. I have 8 minus 3, so t to the 5th. 3 minus 1, because s is just s to the 1st power, so that's s squared. And then 8 over 16 reduces to 1 over 2. So that's our answer. Alright, so let's look at this problem and try to solve it using what we talked about before. So from last lesson to this lesson, so I see I have p's on the top and the bottom, and I know that there's more p's in the denominator, so I'm just going to reduce this fraction to being 2/3, and then p to the 5th on the bottom. I'm going to raise everything else to the 4th power. Now you're going to distribute that 4 to the 2, to the 3, and to the 5. So you're going to have 2 to the 4th over 3 to the 4th times p to the 5 times 4 power. So 2 times the 4th power is 2 times 2 times 2 times 2. The 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. On the bottom, the p becomes p to the 20th. And then we have to deal with the 3 to the 4th power. So 3 times 3 is 9. Let me write this down. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that is our answer. So if we can simplify before we use that to the power 4, it's going to make our lives a lot easier once we keep going. Okay. 0. 0 to the 0 power doesn't exist, but anything to the 0 power is 1. Why? Because 7 divided by 7 is 1. X divided by x is 1. We've known that for a long time. So when we look at this, if I have 7 to the first power over 7 to the first power, 1 minus 1 is 0. So 7 to the 0 power has got to equal 1. The same thing when we look at our x's. Alright, next two problems to try. Pause the video for a second, try these two, and then when you want to pause me, I'll go over them. Alright, this first one, anything raised to the 0 power is how much? 1. That's it. We're done with that problem. Second problem, if we take and rewrite this as t cubed divided by t, I know that the s to the 0 is just 1, so I don't have to write that. Next I go 3 minus 1, which is 2, so t squared is my answer. Negative exponents. If a exponent's negative, it's not happy, hence the unhappy face. If you move it to the other side of the fraction, you make it happy. Alright, so let's take a look at a couple examples. If I've got y to the negative second power in the denominator, I got to move it up to make it happy. 2x y squared. We're done. These two terms, the a to the negative 4 and b to the negative 1, need to be flipped. So we're going to go 3, b to the first, make it positive, and then a to the 4th power on the bottom. We've made our exponents positive, so we have happy fractions. Alright, last few examples. Try these, and then we'll go back and we'll look at these. So this first one is, we're just rearranging some of our variables. So the x to the negative 6 and the y to the negative 4 get flopped. So you're going to have y to the 4th power all over x to the 6th, y to the 9th. Next one, you're going to look at your exponents. I'm going to rearrange this. So I have 75 over 15, and then I'm going to have p to the 3rd power stays, p to the 5th power stays on the bottom. The q's switch, so q to the 4th is now on the top, q to the 5th is on the bottom, and then r to the 8th is on top. Now we have to start subtracting, and also dividing 75 by 15. So let's start with the 75 divided by 15. So 15 goes into 75. Let's see, 15 times 2 is 30. 30 goes into 75 evenly twice, so that's 4 15s plus another to get us to 75. So that means we're going to have 5 on the top. I have more p's on the bottom, so when I subtract, I'm going to have p to the 2nd in the denominator. Q's, we have q to the 1st, that's going to be on the bottom because same rules with the p's. And then the r to the 8 stays on the top. And now you're done. Alright, one more slide. Oh, nothing. Alright, well, questions. If you've got questions for me, the next time you see me, make sure you ask those. We'll move on from this topic, practice it a little bit, and keep going with this particular topic of polynomials.